Student. Myself, M K Sonawane, lecturer of mathematics, Sanjivani Junior College, Kopargaon. Today we learn the topic quadratic equation. We should know the basic aspect of the quadratic equation and where we have to use this quadratic equation. I know already you learned this chapter in 9th and 10th standard, but still we required some basic concept of quadratic equation. So let us start this chapter, and we have to identify the types of the equation. Definition: in mathematics, a quadratic equation is a polynomial equation of the second degree. The general form is ax square plus bx plus c equals to 0. Now here, second degree means the power of x should be 2, that is x square, means a term containing x square is necessary for the quadratic equation. Here we use three constants like a, b, c with a not equals to 0. Suppose a equals to 0, the equation become a linear equation, means simply we get bx plus c equals to 0, hence there is a no second degree term. The constant a, b and c are called respectively the quadratic coefficient, or in short coefficient of x square, comma the linear coefficient, that is coefficient of b, x, and the constant term or free term which doesn't contain x. Next, quadratics and root. First, quadratics. The polynomial of degree 2 y equals to ax square plus bx plus c. Assume that this ax square plus bx plus c equals to 0 is a quadratic equation. Again the same condition, a should not be equals to 0. For example, 5x square minus 3x plus 3 equals to 0. It is a quadratic equation because it contains x square. The name quadratic comes from quad, meaning square, because the variable gets squared. Now here this s is silent, say quad, like x square. It is also called as equation of degree 2. Again be careful, what is meaning of degree 2? Power of that x should be 2, means square term. Now consider roots. What is the meaning of roots? Root is nothing but we have to substitute some values for x so that we get 0 on both sides. A number alpha is called the root of quadratic equation ax square plus bx plus c equals to 0. Again same here, a should not equals to 0 if a alpha square plus b alpha plus c become a 0. Therefore, x equal to alpha satisfies the equation ax square plus bx plus c equals to 0, or we can say that x equals to alpha is the solution of equation ax square plus bx plus c equals to 0. In short, that x equals to alpha is called as root of equation. The root of quadratic equation ax square plus bx plus c equals to 0 are called zeros of the polynomial ax plus bx, ax square plus bx plus c. Now see here, this is the actual quadratic equation. Clear? More examples of quadratic equation. Now here 2x square plus 5x plus 3 equals to 0, then this one a equals to 5, a equals to 2, b equals to 5 and c equals to 3. Also we get the new example like x square minus 3x equals to 0. Now observe it carefully. There is no coefficient of x square, or it is 1. We cannot write 1 into x square. That's why simply x square. Minus 3x. Again, coefficient of x is nothing but b. Therefore, value of b is minus 3. Now please observe that middle sign. And where is c gone? Well, c equals to 0 is not shown because something plus 0, it is no meaning. Next, 5x minus 3 equals to 0. This one is not a quadratic equation because it is missing the term x square. In other words, might be a equals to 0. Therefore, a into x square becomes 0. Some hidden quadratic equation. So far, we have seen that the standard form of quadratic equation, that is ax square plus bx plus c equals to 0. But sometimes a quadratic equation doesn't look like that. Means here we have to shift some terms either on LHS or RHS depending on the condition. The first example, x square equals to thrice x minus 1. Now in this case we can move 3x minus 1 to the LHS left hand side. We get x square minus 3x plus 1 equals to 0. In this case a become a 1, b become a minus 3 and c become a 1. Now in the second example, 2 into w square minus 2w equals to 5. Now here we have to simplify or expand that bracket first, means simply multiply by 2. Here might be chances of silly mistake, that is we simply multiply by w square, not 2w, because sometimes students may say that yes, 2 is already there. While writing there might be a chances of silly mistake. Please don't do that things. So simply go with the straightforward multiplication. 2w square minus 4w minus 5 equals to 0. Now how this minus 5 become here? Now here they are shifting this 5 to this side, so it become a minus 5. Now here a equals to 2, b equals to minus 4 and c equals to minus 5, like that. Next, z into z minus 1 equals to 3. Again in the first look we observe that there is no terms containing square, but while expanding we get z square minus z minus 3 equals to 0. Be careful. Hence here a equals to 1, b equals to minus 1 and c equals to minus 3. Fourth example, 5 plus 1 upon x minus 1 upon x square equals to 0. Again here that x square goes down to the denominator. So simply we have to multiply both sides by x square. While multiplying x square we get 5 into x square plus 1 into x square upon x square. 1 x get cancelled, simply x is remain here. Please note down this thing. Minus 1 into x square upon x square get cancelled, simply minus 1 is remain. So we get the new quadratic equation like 5x square plus x minus 1 equals to 0. So here a equals to 5, b equals to 1 and c equals to minus 1. Now these are the some hidden quadratic equation, means initially we cannot treat it as a quadratic equation, but after simplifying we get the form like ax square plus bx plus c equals to 0. Now how to solve it? There are three ways to find the solution. We can factor the quadratic equation, find what to multiply to make the quadratic equation. That is our traditional method. Means select two numbers such that their product should be a into c and their addition should be equals to b, or in equation form we can say that the product of two numbers is equals to coefficient of x into constant term, x square into constant term, and their addition should be equals to plus minus b, or that b coefficient of x. We can complete the square method, completing square method. So we can find the third term tt. We can use the special formula, that is x equals to minus b plus minus under root b square minus 4ac upon twice a. Thus ax square plus bx plus c equals to 0 has two roots alpha and beta given by alpha equals to minus b plus under root b square minus 4ac upon twice a, and beta equals to minus b minus under root b square minus 4ac upon twice a. Now here the one concept, that is a discriminant, you can say that delta or del or d, capital D. The expression from the formula x equals to minus b square plus minus b square minus under root b square minus 4ac upon twice a. This b square minus 4ac is called as a discriminant because it can discriminate between two possible types of the answer. It can be denoted by d. So we have three cases. First one is that d is positive, then we get two real roots. If d is 0, we get identical or same roots or same answer. When it is become a negative, we get a complex solution. Means half part of that solution root is real and half part is imaginary. Means if you consider under root of minus 1 equals to suppose x. So what happen then? While squaring we get x square equals to minus 1, which is not possible. So here we cannot say that any number having its square is negative, hence it is a complex. This is the new aspect in the 11th standard, that is complex number. This is another separate chapter, we will see it later on, but here only consider that quadratic form, that is complex solution. Using quadratic formula, just put the value of a, b, c into the quadratic formula and do the calculation. For example, 5x square plus 6x plus 1 equals to 0. Here coefficients are, means values of a, b, c are a equal to 5, b equal to 6 and c equals to 1. On putting values of a, b, c, we get x equals to bracket minus 6 plus minus under root 6 square minus 4 into 5 into 1 upon twice 5. So here that discriminant equals to 16, that is positive. Means here we get two distinct root, two separate root, because root 16 is nothing but 4. So x having the value minus 6 plus minus 4 upon 10. So it become minus 6 plus 4 upon 10, which is nothing but minus 2 by 10, that is minus 2.5, minus 0.2, minus 0.2, or minus 6 minus 4 upon 10 become a minus 1. Therefore, x equals to minus 0.2 or x equals to minus 1. Check. For x equals to minus 0.2, we get the 0. Also, for x equals to minus 1, we get the 0. Hence, we can say that this is the solution of this equation. To factorize a quadratic to find the value to multiply the quadratic equation.
हो गया, आ सकते हैं हम।